Okay, I just got done cleaning up the head here. Got all the oil and stuff off, got the valve guides off. So I'm going to go ahead and bead blast this and clean up the combustion chamber and the ports. Not the outside of the head, but just all the inside stuff that I don't like being full of carbon. So I can go back here to the blasting machine, which is way in the back here. Get to walk by all the mountains of crap. Projects, lots of projects. Alright, so here's our blaster. This here we get to go ahead and do some blasting, which you can't see very much of. So go in there like this, and then we got a nice nozzle right here that sprays a lot of junk out of there and cleans them up. So we'll come back and show you what it looks like in a few minutes. Alright, we're done. Pull this down a little bit. So there's what it looks like. All cleaned up. Now Harley powder coats the whole casting when they before they machine everything. So that's why you'll see powder coat inside your chambers, inside your ports down in here. Intake ports, that's all that's not carbon, that is the powder coat. Because like it's a lot easier to powder coat the whole thing after you cast it and then machine it later, because then you don't have to deal with taping stuff off and making sure you got the powder coat where you don't want it. So that's how they do it. So you'll see a powder coat in all kinds of places you just don't think it should be, but oh well, that's the way it goes. Oh, in case you want to know what the beads are, there you go. That's the beads. So now I got to clean all the beads out of this head right here, which is going to be fun. It always is. Usually requires about 3 cleaning processes. It's already been through a couple already, just to get to this stage, and I'm going to clean it probably 2 to 3 more times. Depends on how much more crap I keep getting coming out of the holes. If the head feels gritty, you keep going. So one of the tricks we do is we use this fine tip nozzle right here, way up here. So instead of using this nozzle here, which is got a long tip on it, which allows me getting down the side of ports real nice and easy, through here and down all this stuff real nice. This does not work very good for going into holes. I'll get rid of that. You can't go inside of a hole. This one here is the same thing, just smaller. It goes down inside of a hole in here. And when you go into a hole and blow on it, all the grit and crap blows out, including the machine chips from when they made the parts. I've blown out knuckleheads, panheads, 30s, spikes. They're all full of chips in the bottom of the holes. So, we have no chips in here right now. So you go in here blowing this, you'll see stuff blow out. Yeah, in my face. You go like that until you don't feel anything hitting you in the face or hitting you in the fingers. So you see how I got built up on my finger already? It's already on the front of this. When you're all done, my finger will be covered with beads and dirt and oil and crap. So that's how you do this. So you got to clean all these things multiple times like this to get all that junk out. Alright, so you clean every hole, get all the junk off. So we didn't get too much of my finger this time. But you do have a buildup on here. Okay. Alright, and we got beads on the table here already too. So you can see the beads on the table right here from when I laid the head down before. Okay. You don't want that inside your motor. it will do damage. Okay, now to get the beads off the outside surfaces and everything else, you got to use some kind of liquid material. So you can use water, soap and water. You can use solvents. You use, preferably not gasoline, kerosenes, and diesel oil. But yeah, if you have to, you have to. But some kind of a liquid product will take this stuff off. So you don't want to get something that's caustic because it'll eat the aluminum up, but you want it to clean all the crap off. So, all right, I'm going to clean this all up and we'll be back. All right, the air compressor just shut off over there, making noise. Okay, here's what the head looks like after you clean all the junk off of it. So now we're going to go ahead and deburr these surfaces and clean up those bad areas. Do have the die grinder. So you're going to pick the ones you want to use. Alright, so we got various tips. Ooh. So whichever ones you need. So you got aggressive ones, you got fine tipped ones, you got small ones with points on them where you can get in there tighter. Then you got a dull one that doesn't do anything, which smooths up surfaces. So you got a combination, all kinds of stuff to use. Alright, get this where you can kind of see what I'm doing. Stupid light around here. So first thing I'm going to do is knock off our crap right here. We'll just use this finer tip one here. See how it works. Sportster motor mounts come in handy for head holders. They work really good for that action. Alright. The reason why I knock this stuff off is to stop detonation. Sharp edges will cause detonation. Burrs right through here everywhere. I don't know if you can see that or not. Get a little closer, maybe it'll help you. Okay, I got this stuff across here. I don't like too much. The gasket's right along that edge, so you gotta be careful about going too far. You don't have to grind it all out, just make the sharp edges go away. I usually like blending stuff too while I'm at it. Okay. Put that back up again. Pull out the dull one. Deburr everything. If you feel anything sharp edge, then you gotta do some more cutting. Okay. Now I gotta do right here next to the valve seat, so you gotta be real careful about that. You don't want to be touching the valve seat, obviously. I usually like using this radiused one more than the sharp edged one. You can touch the steel seat, but not the actual seat area where the valve goes on. Low RPM, you got more control. Try to smooth it once, a bit big, but I think we can get in there with it a little bit. That's the original chamber roughness there. Alright, so I got that smoothed up right through there pretty nicely. A little bit too close there for the blow up view. Okay, now I'm going to go ahead and knock this big one off right here. There, so it doesn't roll over on me when I'm trying to work here. Okay, so you got to be, this one you got to be careful not taking off a lot. I think this little small one's going to be our best one. So we're not trying to cut it all out, we're just trying to deburr it. smoothing one now. There you go, nice and deburred, nice and smooth. Looks like crap, but doesn't really hurt anything. And we got a couple over here next to the valve seat on the intake side. So just like we did before, we're going to use a small sharp one, and then we're going to come with the dull one to do the final. This one's right into the valve seat, and there's a big nick in the valve seat too. Okay. Yeah, get the camera off, it's easier. So, you can see that's all deburred. You can see how the valve seat's right there, I ground up to it. There's also a big nick right there, I don't know if you can see it or not, but it's there. So that one went right into the valve seat areas, which is not the best spot to be, obviously, but oh well. This one here is just on top of the seat area. Like I said, this one dug get a big chunk right into it. So anyway, all that's deburred there. All this stuff's deburred now. So we'll just run and do a little sand across here and you make it nice and smooth. Now the spark plug hole was never deburred from the factory, which I don't like. I always like deburring these edges right here. I don't know why they leave them so rough. Because they're lazy. Take another special tool to do that. I don't want to spend any money. Typical Harley. There you go. Multiply that times 2 times 500,000 bucks a year. There you go. So just knock those burrs off. You don't have to worry about any kind of detonation. All the sharp edges are gone. Alright. Well, if you accidentally slipped in here with a port job, it wouldn't hurt to knock off these burrs right here. That'd pick up a lot of flow real quick. Yep. That's a bad idea. Right there, you pick up a lot of flow real fast. Let's knock that from there out, blend it in, call it done. That one don't do squat, leave it alone. This side over here, you got the same sharp edge, lightly cut it, don't get too much. Mainly on this side where you gotta do all this work is right here. This lip roll through here, it's got sharp edge in there, it's probably that bolt in there. So I'm just gonna hit it real quickly with my dull one. I'm being paid to do a port job around here. Those edges, more sharpness up in here. Means there's more burring going on. So bolts vibrate around, they make sharp edges everywhere. It's also the same thing you do when you do a port job. Imagine that. Knock off the burrs. Okay, that cleaned that up. That little bit I did there will help the flow. A little bit, not a lot, a little bit, but see, I lightly raised it there just to get the burrs off. It didn't grind the whole edge away like it should, but so I'm not being paid to do a port job. Okay, so that's how you do it. You deburr it like that. Now, if you want to weld it, then we come in here and weld that up there. We weld this right here. Grind it flat, call it done. So, I don't remember if I was supposed to do that or not. Can't remember. I don't think he wanted me to do it though because it's more money. So anyway, this here is fine the way it is. So I can weld it. It's right there. Have to heat this thing up, warm it up, go in there and weld it up, grind it smooth, make it look pretty, call it done. So I don't know. Think I should do that? Leave and go home. Looks like crap the way it is though, doesn't it? So, yeah, who knows? What should we do? Do a nice job or just do a good job? Yeah, we'll see. I'll come back.